Las Vegas, this is NAB Show Live, produced by Broadcast Beat.
Good afternoon, everybody. I'm Janet West, and I'm delighted to welcome you back to NAB Show Live here in Las Vegas. This afternoon, we're going to be talking about remote broadcasting. I've got four gentlemen here who know an awful lot more about it than I do. So I'm going to start by introducing, this guy's not my co-host, by the way, we just ran out of chairs. So I've got Joep Jensen, who's the CEO from Aperi, and to his right is Bob Bush, who is Sales Director for Multidyne Electronics. And next to him is Michel Bais, who is Managing Director of Mobile Viewpoint. And finally, but not last, is Martin Paskin, who is the Systems Integration Manager from Gearhouse. Now guys, it's a long time since I worked with Canadian Broadcasting and we had our first HD truck. A lot of things have happened since then. So what technology today is enabling remote production, and what are the challenges that you're finding?
Well, the key to remote production and make it efficient is actually IP. So open standard Ethernet to use all the telecom and data center practices on a long distance to get the live pictures back and to do the programming remotely.
Okay.
Yeah, to make it low cost, of course. You see that, of course, there is less and less money available in live television, so we also see a lot of need for low-cost transmission equipment, not only satellite vehicles, but also the IP bonding technology we make, and also that you integrate quite low cost directly to social media.
Okay.
I think the key thing is trying to work out what it is that you're trying to achieve with remote production. So technology is an enabler to the remote production, but we need to identify exactly what's required from a production processes enable to do that remote production, and what the requirements are around why we want to do remote production. And then once we've understood those things, then we use the different technologies that are available, of which there's a huge amount. We've had IP technology around for years, having links coming back from the remote production to the studio, but now we're seeing people wanting to do lesser sports events, which never used to be on, now being put onto video on demand services, and we're seeing people want to reduce their operation costs as well. So it's trying to understand what those key drivers are for remote production, and then how we as technologists can put that forward into to what it is that we propose.
Are dedicated appliances better than streaming apps?
Yes, because we make them. I'll be sure it is. When you check, for example, an app on your iPhone and you film live with it, like Periscope, it's okay, but it's not great. You get hicks and freezes, and also your audience gets tired with it. So as a production company, you see, you have to invest a little bit more money to get a good quality video out there, because although people accept lesser quality, they don't accept hicks and freezes and audio stutters.
Yes, but I think we need to clarify what apps are, right?
Right.
So Aperi is a company that actually makes a real-time platform in software that you process all the encoders, decoders, all the switching that you need to do live, all in the native IP domain, and all real-time.
What do you actually mean by native IP infrastructure?
Well, that maybe the camera has still an SDI output, but then the moment it goes into your processing devices, appliances, that actually it's converted once to IP, and it stays in IP all the way maybe to the monitor with an HDMI legacy output. But the processing, the switching, the DVE effects, all those, the multi-viewers, all is natively in IP. And what we promote with Aperi, which means open in Latin, is use the open Ethernet standards for all of that. And what we have shown last year at the Euros, the soccer championships, that actually live 4K remote production on 600 kilometers, you can actually do fully real time and do all the processing in software. So, and we call that apps. So it's not the app of an iPhone, obviously, but it's a professional app, and you can change the 4K camera formats on the fly to do a next remote production somewhere else in the world.
Right. Yeah. What happens and what are the challenges for multi-venue productions?
The challenge is to get enough bandwidth, I think, on location. But sometimes people really think that an ADSL modem or a cable modem is enough. downstream, but then you want to go upstream, there's a big issue suddenly. So there's a lot of people make mistakes over there, and then suddenly they still need to gear in satellite connectivity to get enough IP bandwidth, do a satellite IP connection to get good production. So that's something people overlook, that there is really need for some bandwidth on the location, which you won't find in Syria, of course, for example.
Yeah. Michel, you mentioned earlier about cost, and I think whether it's remote broadcasting or anything these days, everybody's interested in cost. But where is the major cost when you're dealing with IP production? Is it that we're reducing costs with smaller trucks, or?
Yeah, personnel and gear, of course. You need less personnel when you can do remote production. You don't need a switcher anymore in the field. You can do it remotely. So you only need a cameraman and a presenter like over here, and everything can be done 600 kilometers away, indeed.
Yeah.
So you save in personnel and equipment, definitely.
Okay. Any other comments on cost?
It's very difficult at the moment because we're seeing new technologies coming in which are still fairly expensive. We're having to use very expensive IT switch fabric.
Yeah.
So at the moment, some of the costs associated with some of the infrastructure may be slightly higher, but then that's being offset by some of the other costs which are being reduced, number of staff on site. The other thing is how you utilise your resources. So if you've got a vision mixer, there are a number of people who are looking at utilising their resources, vision mixers, EVSs, graphics, for instance, where they may be able to centralise those and then be able to move those from one event to another event to another event. So it's very difficult to try and work out where those costs are, because it's not a simple, it's just in this one OB truck or it's just on this one event. And then the other issues are, you may have your connectivity for one event between site A and site B, but then when you want to take that to somewhere else, there are other costs associated with maybe getting the last mile of connectivity, or you may want to take that on to another country, for instance, and connectivity changes there. So there's a lot of challenges for both the operational teams and the technology teams to make this work.
Yeah, I think it comes down to cost and bandwidth availability for your infrastructure.
Okay. If you're, remote and you're transmitting a signal, for example, just from news or a single plan production, what else is involved when you're including social media and other ways?
What we see is also what you have to think about is do processing in the backend like transcoding. For example, when you go directly to YouTube and Facebook, it also to Periscope. Periscope only accepts 800 kilobits at high resolution, but it doesn't look awful, to be honest. So you have to do really very good post-processing to get your high-quality source from the field into such a social media stream. And we try to enable that with high-quality transcoding equipment, also cloud-based. But that's one of the challenges I see. When you look at the social media streams, the quality is sometimes really doubtful what you have to look at.
Yeah, and there's so many different formats that you have to deal with for all the different flavors of social media that you have to put out there for.
Social media was one of the interesting things which were picked up in a recent SVG conference in the UK, where there was a panel with production assistants on there. And part of the discussion went down the route of having less people at a venue, particularly at a sports venue. And conversely, they were saying that there was a need for social media people who can get their signals and everything back at the studios, but they were actually having to find more space in the OB trucks so that social media people can be out in the field as well. So again, it's a case of looking at the production processes and production values of the organisations as to what it is that's important to them. So it is actually putting challenges and adding pressure to some of the OB companies like ourselves.
But the social media side is already in our IP.
Yeah.
So if we talk about remote production side also going to IP, you make one translation step less in the whole process, and you could be a lot more efficient and flexible and do probably more with less if you can do the whole chain in IP.
Okay.
So it also is an interesting point with the social media today, is who's first. Because what you see today, if you're the first, then everybody links to you, to your Twitter account or to your Facebook page. So what you see is also a challenge for a lot of production companies. So how I am enabled, I'm the first one to post my nice content. So if I produce Formula One, then my neighbor posts on his Facebook, he gets all the hooks and all the links. So that's also a challenge we also try to solve with our software, that you can be within 30 seconds, you get your clip live on your Facebook. So everybody links to you with your Max Verstappen crash or whatever.
Okay. I've heard the expression live video of a bonded IP. What do you mean by that?
That's technology we use. What we use with bombing is that you take several IP channels together in one big IP channel. And that ensures high quality but also a kind of redundancy. So if one IP channel fails, you automatically use the other one more. So we bombed quite a lot of times satellite IP with just 3G, 4G IP. You see that also to lower the production cost, people go over IP satellite like KA in Europe. But that's not always that stable due to rain fading or clouds or whatever. So you need to have a kind of second bonded channel to ensure that you keep stability in your production.
Okay. We talked yesterday in one of my shows on virtualized playout. What can you tell me about virtualized production for remote production?
It's basically doing the same thing. It's that you spin up channels and formats and scalers and etc. in software, and when you don't need them, you spin them down, and you haven't brought any new equipment on, or you did any recabling. So in production, you can do that now as well. So, but you need real-time platforms to do that. While the playout is less real-time, if you do a second to do a transcoding, that's all right. As long as all the channels are delayed with 1 second. In live production, you don't have that second. You need to be in milliseconds ready, and that's kind of the next step. And coming back to the cost of remote production. So instead of driving with your trucks to all the venues one by one, that's very costly. If you have an IP infrastructure, an IP network, and actually you don't have to use the software to run that infrastructure for that match, because there is at that venue no match, and you don't pay for it. So virtualization gives you also an enormous cost benefit, that if you, for example, and that's breaking news for the NAB show for us, together with our partner Ericsson, we are going to, over the summer, have a 30 stadium plus implementation of remote production somewhere in the world, I cannot say where, that will be completely networked up. But actually the broadcaster, the sports broadcaster, who is a global player, only has 5 matches at the same time. And so they are only paying for the infrastructure for the 5 matches. Although the next match could be somewhere else, but then the floating licenses move and the costs move with that match. So they don't have to pay all the time for 30 installations.
Oh, okay, I see.
So that is an enormous cost benefit for if you go into software processing rather than the hardware processing that we have today.
I remember when I was involved in remote broadcasting, actually in Belgium, next door to Amsterdam, a few years ago, there was one problem that not a lot of places were equipped with fibre. Is that a problem today, or is most of the places equipped with fibre?
It depends where you're looking at. We've done some carried out some proof of concepts. We've worked with a Perry for the Euros in France, which is extremely well catered for with fibre. But then we've carried out some other proof of concepts, like in Australia, where the last bits have been a problem, and we've had to use packet IP to make the last elements of it work. So. It's not quite as simple as saying we've got dark fibre from point to point. Equally, there are some countries in the world that don't allow you to actually have dark fibre from point to point for political reasons. Therefore, you have to use packetized IP over those connectivities. So they're real challenges that we all have to think about when we're designing solutions for various people, because it depends on where around the world they're going to be. You can't design a system which is just going to work on dark fibre, because they may make a decision to do another event somewhere else. And just literally, like I said before, getting that last mile can actually be a real problem.
What are the advantages of using a high data rate for, the advantages of fibre when you're using a high data rate?
Well, the whole point is, how many signals do you want coming back? Are we doing something in HD? Are we doing something in 4K? How much compression do we want to put on the signal to go from point A to B? How many signals do we actually want to get back? Some of the broadcasters I've been talking about who are really looking into doing real live remote production They started off simply by thinking, we need to bring back all the cameras in HD. It says, well, do you really need to do that? Well, that's our biggest problem because of the cost of doing that. But there are other ways of doing this. We shouldn't necessarily look at remote production in the same way we would do a traditional production at the moment. So we may look at thinking about bringing back multi-viewer screens back and maybe only 1 or 2 HDs. We might be looking at some things actually coming back in SD where sound monitoring, for instance, doesn't need to be in HD, but actually they're really interested in the latency issues. So there's a lot of different things for different members of the production crew that need to be catered for.
Also your target audience. Do you want to go only on the social, or do you really want to go on TV on high quality?
Yeah.
So sports events require high bandwidth, high quality. But a very basic thing like a basic or a bicycle race with a lot of movement can also be a little bit lower.
Yeah, you can take fiber, a single fiber, and put literally hundreds of signals over it, and that can be 12 gig. You can be just about anything. It can be your audio, it can be your data, it can be IP as well. So that can go extended distances where you're just not going to accomplish that over copper, and you won't have any kind of the latency issues like you have over IP.
So you mentioned going back to SD, but we've been talking 4K and they're still talking 8K. What's that going to do to the remote broadcasting industry?
Well, that may
a headache or an opportunity?
No, it's an opportunity because there are compression algorithms that take a visually lossless 4K signal into the existing bandwidth of 10 gig or even lower. So I think that's manageable. 8K is another story. That's we need to go to the higher bandwidth is on the network, but 4K is absolutely no problem at all. And frankly, the 30 plus stadium project that I just mentioned will use 4K, quite a few, and bring that all back in 4K quality to the production hubs.
Right. Okay. What are the advantages? I seem to get loads of acronyms from my panelists. What is CWDM?
That's coarse wave division multiplexing.
Okay.
Basically,
what is that?
An easy way to think about that is you've got different wavelengths of light, or essentially colors of light. So what you're doing is you're putting different signals. Camera 1, camera 2, camera 3 are on different colors of light, and then you take those through a filter and that muxes them onto a single fiber. And you can do that with your audio, with your data, with just about any type of signal. So that's where you can literally, in a combination with time domain multiplexing, you can actually get a vast number of signals over a single piece of fiber.
Okay. So that presumably is an advantage to you guys or the customer?
I think probably both, because it eliminates, the need for a big snake bundle of cables where you used to have one with productions down to really, knocks down the number of cables you need to roll out because you can put so many signals, the density of it over a single piece of fiber.
Okay, something close to my heart is sustainability in this world of electronics. What's happening with respect to design of outside broadcast trucks, etc., to be more sustainable? I know the BBC were looking at trying to make a sustainable OB truck.
Well, if you have a remote production network, then less equipment needs to be at the venue. You still need the cameras.
You still got to have a truck for the cameras.
You still, and maybe you want, even for the high-profile matches, you still want the production crew to be actually locally at the stadium. But most of the equipment, 95% of equipment, can actually be in one central place because the network will do all the processing for you. So you save a lot in weight and in size of equipment, and you could make a beautiful production environment, very creative. Add the social media crowd that maybe wants to better engage with the whole production during the match. So it creates all kind of new opportunities. But the truck will be a lot lighter, and the equipment, you only need that if you have 5 matches at the same time. You need for 5 matches equipment, but if you have to truck that around in the past, you need a lot more than that. So you save a lot of equipment as well.
From a system integration perspective, it's very interesting times at the moment because we're still seeing an awful lot of tenders coming in for traditional standard broadcast OB trucks. there's still a nervousness into moving into IP, even though there are a number of IP trucks that have actually been delivered. And particularly in the US, we've seen more of a requirement from the OB companies and the broadcasters and the SIs in the States asking for 12G SDI, because there's still a nervousness about OB vehicles with using for UHD. In fact, Gearhouse Broadcasters just built a UHD truck for the US, for our US office in LA, which is based on quad SDI. So there are still traditional vehicles being made, but at the same time, there's a lot of people looking to the future. How can I future-proof my vehicle? How can I build something which is for HD today, but I want to build it up and still use it in maybe 5 years' time for UHD,
yes,
particularly where sports is around.
Yeah.
Indeed. So this is where the idea of maybe either a hybrid vehicle or moving into the IP domain has worked. BT in the UK has been very much on the forefront of what's going on, and they've had 2, and they're now on their 3rd OB truck, which is all IP. So it's a very mixed world, very interesting world. There's a lot of people who need to learn about this technology because it's changing for all of us.
Talking of which, learning about it, education. Do we have the skill set amongst technicians and engineers to deal with this? Or have we got a problem?
That's the real issue.
Yeah.
It's the people and the know-how in the industry.
So how are we going to solve that? Because this has come up in a couple of sessions, trying to, with the changing times in our industry, how do we get the right skill set?
More of these sessions, for
More of these
example.
sessions, okay, great.
Absolutely.
I'm hired.
I think the biggest issues, we've all had IT switches in our infrastructures, but nobody's ever had to learn to use serious data center switches unless you're looking at things like media asset management centers in large production facilities. If you're now putting that into an OB truck, you've got to skill up people to understand and actually not be afraid, because actually it's not that difficult. Once you learn what you need to know about it, and also making the facility resilient. So you're not going to stick one IT switch in, you're going to stick at least 2 IT switches in to make the facility work. Where it really matters is how we do control and monitoring, and there's still a lack of decent control and monitoring tools out there to make the engineers, the broadcast engineers at the moment, confident with what they're actually looking at. And it's all right saying, I'm going to look at this multicast here and excuse me, and look at that multicast that's coming into the switch and look at that on the monitor, but actually I want to look at the output. So there's a lot of understanding around their infrastructure that they need to do.
This has been I'm really sorry, Michel, we're running out of time. This has been a really interesting conversation. I'd love to have continued. So I'd really like to thank my guests, Bob Bush, Joep Janssen, Martin Faskin, and Michel Bais. And thanks very much for joining us. Stay with us, guys, because in a few minutes we will be talking about media logistics. I'm Janet West, and see you in a few. Take a break.